Hello, our project is called Codeblox. Codeblox is a set of blocks with programmatic syntax that students can piece together to form programs. It aims to teach kids how to code and provides a more tactile alternative to existing programs like MIT Scratch. Codeblox can be broken up into three subcomponents: a main tile, a set of slave tiles, and an interpreter. The slave tiles form the programs, while the master tile contains the connection to the interpreter via serial communication. The interpreter program will run the program and then display the results in a GUI.
Alright, let's show off some example programs. Let's start with something simple, like printing out some values. So you just click the tiles together, print 8, print false, and print 1. So now let's run this. Alright, let's do something a little more tricky now. Let's do some arithmetic. So let's define a variable x, set it equal to 8 plus 1, and then print out the value of x. We can run this one now. Alright, let's do an example with conditional logic now. So let's define a variable x and set it to equal true. Then we'll check if x is true. And if so, we will print 1. Now let's introduce a bug to this code and see how it handles it. Let's assign x equal to 8 and check if 8. Oh, whoops. Again, as you saw, you program them by putting these paper pads on top, and these paper pads have a binary encoding on them that is read by the 6 reflective sensors on the tile to tell the tile which type of tile it is. These are generic and can be used with any pad and swapped out. The tile itself is a custom PCB powered by 2 AAA batteries, an Atmega 328P microcontroller, and uses 4 pairs of IR emitters and transmitters and receivers. And again, like I said, these 6 reflective light sensors to measure the encoding. Beyond that, it's a pretty simple circuit with a serial interface for debugging purposes and an ISP for programming. The way these tiles connect to each other is by these 4 neodymium magnets that have their polarities aligned such that you can connect them on the axes that we want them to be connected on. And they can also be flipped 180 degrees, but if you connect it 90 degrees off, they slightly repel each other, which makes it difficult to connect these incorrectly. And like I said, these can be flipped 0 degrees or 180 degrees, and it will still work. The tile itself is symmetric.
So let's talk about the firmware within the PCBs. The firmware can be kind of broken up into 2 different layers, the communication layer and the actual application layer. So for the communication layer, it's a synchronous application that has the tiles start out in sleep mode, meaning that they only draw a few microamps. That's so that you don't have to explicitly turn the tiles on or off to begin communication. They can just stay in sleep mode and can last for up to 2 to 3 years like that. The way that a tile begins communication is when it's woken up by an external interrupt, which is triggered by an IR pulse from one of its neighbors. Then it begins its synchronized communication. The tiles operate in a clock speed of 100 Hz. They are synchronized by the tile's internal timer, which fires every 10 milliseconds. When a tile receives a pulse, it uses its internal clock to measure what bit has been received within a word so that it can read the words correctly. While the hardware is synchronous, the application layer communicates asynchronously on top of it. How it works is that the tiles will form a graph-like structure in which some tiles will be parents to others, and there will be children to those tiles as well. When a tile receives information about tile encodings from its children, it then sends that information asynchronously up to its parent until all of that information has reached the master tile. So we can see an example in this picture. In the bottom right is a very simple topology with a master tile, a print tile below it, and a 7 tile to its right. When the master tile wakes up, it'll send a request parent message to the print tile. The print tile will immediately send back its own information, which is composed of an X coordinate, a Y coordinate, and its encoding, where the coordinates are relative to the tile itself. While that happens, the print tile will also send a request parent message to 7. 7 will accept print as a parent and then send its own information, which again is X0, Y0 encoding 7. Once the print tile has received that information, it will asynchronously send it up to the master tile, where the X coordinate is now 1, the Y coordinate is 0, and the encoding is 7. When the print tile receives a done message from 7, and also has timed out from its left and bottom side, the print tile knows that it has received everything it knows, and then it sends a done message to the master tile. And since the master tile can only have one child to the bottom of it, the master tile knows that it has received all of the tiles that exist in this topology and can send it to the interpreter.
Once the master tile sends the configuration of all the tiles over to the laptop, that's when the interpreter takes over. The basic function of interpreters in general is to break down the code you write and actually run it, while looking for errors along the way. In Codeblox, the interpreter is designed to handle a variety of basic syntax that you'd see in an interactive programming language, such as numbers and booleans, basic arithmetic and logic functions, variables that you can assign values to, loops, if and else condition blocks, and an output print statement. Since Codeblox is meant as a learning tool, we expect children to encounter many mistakes while building their own programs, so our interpreter also features a handy error checking and reporting mechanism. The interpreter works in a sequential way, starting from the top left of the program. It expects each line to start with a conditional block, which would mean something like an if, else, or a while, or a command statement, in our case a print, or a variable assignment. If you've programmed in Python or C before, you'll notice that something like declaring a number, which is perfectly valid in C, is invalid in Codeblox. This is because we wanted the instruction set to be more intuitive for children who are just starting to learn programming. The interpreter also does basic type checking for arithmetic and logic functions. Adding 5 and 3 makes sense, but adding 5 and true does not, at least in the conventional sense. To keep with our goal of making Codeblox programs easy to construct and understand for children, our interpreter comes with dynamic type checking. This means that even though the children don't need to worry about the types while constructing their programs, while running the code if something like 5 plus true is encountered, our interpreter will report an error.